Okay, so now, so let's start back at looking at kind of where when we started talking about optimization, we looked at this function. And, we reflect it back to the single variable. And what we're going to do differently this time is say, well, I want to find the highs and the lows, the absolute maximums and minimums in some closed interval. So maybe I'll choose this interval. Maybe I'll choose the interval 0 and 3. Okay? So what I want to do is find the highs and the lows, the absolute maxes and mins. Now, on this interval, 0 to 3, whenever you have a closed interval like that, you're guaranteed to have a maximum, you're guaranteed to have a minimum. So let's see if we can find those. Now, here's the thing. Remember, with the single variable, when we have a closed interval like this, we know that the maxes and mins can occur at the endpoints or at critical numbers. So we'll just try those. We know that x equals 0, that's at an endpoint. X equals 3, that's an endpoint. Now we get the critical number. So this is 2x minus 2. And just like before, we said, well, 2x minus 2 equals 0, so x equals 1. Now, remember, so once we get those, what we do is we go back and we test. We got 0, 1, and 3. And we just plug those back into the original function. And I'm going to plug them back into x squared minus 2x. So, of course, when I plug in a 0, I get 0. When I plug in a 1, I get negative 1. And when I plug in a 3, let's see what I get here. I get 9 minus 6. What is that going to be, about 3? Okay. So here's what we've got. We've got our maximum is at 3. So here's the thing. The max occurs at x equals 3. Oops, go back here. The max occurs at x equals 3. And in this case, it is 3. Okay. Now, the minimum occurs at x equals 0. Yeah, at x equals 1. Sorry about that. And it is negative 1. So we get a max and a min. Now, notice the max occurred at the endpoint, the min occurred at a critical number. Okay. Now, what we want to do is expand that idea to something like this. So, over there we had a closed interval. X goes from 0 to 3, closed interval. So we can test those endpoints. Well, now what we want to do is we want to expand that to 2 independent variables. And now we don't just have x goes from one number to another. We also have y. So if you look at this, we've got this function of 2 independent variables. And then over here, we've got our boundaries. In other words, this is the interval that we're looking at, or the region. So we're told that x, it says the absolute value of x is less than or equal to 3. So that means that if you go over 1, 2, 3 right here, and 1, 2, 3, well, 1, 2, 3 here, it disappeared there. Oh, disappeared. Ah, well, maybe I can draw it. See if this works. Ah, it disappears. Okay, so let me get rid of this thing. Okay, so what we've got here is we've got these endpoints here. So what I've done is I've just sketched this region right here. So this point over here is negative 3, negative 2. So let me write that. Negative 3, negative 2. This is negative 3, positive 2. And here is 3, 2. And 3, negative 2. So what we want to do is find out, well, we want to find the highs and the low points on this closed region. Well, the first thing we need to do is we need to figure out what's going on the inside. Just like we did with single variable calculus, we find the critical number and look at what's going on the interior of this region. Then we want to test it on the edges, and then test it at the points, right, the corners. Okay, so let's start off looking at the interior. So we do that just the old way. We have the partial with respect to x. Let's see here, minus 6. And that's got to equal 0. And then we take the partial with respect to y. And that's going to be negative 3x minus 2y plus 2 equals 0. So both of those things have to be true. And then we'll get a number. We'll get an x and a y. And then we can use our discriminant to see if it's a max, min, saddle. So here we go. I've got 2x minus 3y minus 6 equals 0, and negative 3x minus 2y plus 2 equals 0. Now, of course, his is a system of equations. 2 equations, 2 unknowns, so we're well suited to solve that. What we get is 2x minus 3y equals 6, and then negative 3x minus 2y equals negative 2. Now, I think I'll solve this by multiplying equation 1 by 3 and equation 2 by 2. So here's what I'm going to get. I'm going to get 6x minus 9y equals 18, right? I just multiplied through by 3. Now, the next one I'll multiply through by 2, and I'll get negative 6x minus 4y equals negative 4. If I add those, I then get that negative 13y equals 14, and that gives me that y is equal to negative 14 thirds. 13ths, negative 14 13ths. Okay? Now, what I want to do now is I need to find out what the x is. So I've got the y, I need to find out what the x is. So I'm going to plug back in anywhere. Let's say, I guess I'll plug into this one right here. I've got 2x minus 3 times negative 14 13ths, right, equals 6. And what I want to do is just solve for x. Okay? Now, these two negatives will make a positive, so now let's see what we get now. We get, and let me go ahead and clear this 13 out. So I've got 26x plus 3 times 14. Well, let's see here. What is that going to be like? 42? 3 times 14 is 42? I think so. 42. And 13 times 6. What's 13 times 6? Let me see, 60, is it 78? Does that sound right? Okay. Now, y'all let me know if I mess up here on my arithmetic or anything else, really. Okay, so I multiplied through by 13. Now I'm going to subtract off the 42. And what is 78 minus 42? I guess it's going to be a 26. Is it going to, no, is it going to be 36? Yeah, 36. So I get this. I get that x is equal to 36 over 26. I think that will reduce some, right? So 2 will go into 36, what, 18 times? Is that right, 18? And 2 will go into 26 13 times? Okay, everybody okay with that? Okay, so it looks like I've got a point here. I've got this point. 18, let me erase this. Okay, so I've got this point. I've got 18 13ths, and then I've got negative 14 13ths. Now, I wonder if this is even a max or a min. Maybe it's a saddle point. So what I want to do is go back and see, well, maybe it's a saddle point. So let me go ahead and find f double prime up here. F double prime, well, not f xx. That's just going to be, is it just going to be 2? Okay. So we've got 2 times, what's y, fyy? Well, that's negative 2, isn't it? And then xy, let's see here. If you have xy here, this is negative 3. So this is minus a negative 3. So here you have negative 4 plus 3. Is it negative 3 squared? Ah, negative 3 squared. That's right. That's right. Okay, let me go back here. See if I can erase this. Okay, so it looks like what we've got then is we've got negative 4 minus 9. Well, that's definitely less than 0, right? So it looks like we've got a saddle. Okay. So we've got a saddle point in there. There's no max or min inside this area, right? Okay. Now I didn't actually calculate what that was, but it's a saddle point. I didn't actually calculate the value. Now what we want to do is we want to go back and we want to actually calculate we want to see if there's any extrema on these edges and at the corners. Okay, so now let's look at these edges here. So here I go. So this can get kind of tedious, a little bit tedious. But let's just look at this. Let's look first of all along the line y equals 2. In other words, let's go ahead and fix y and see what we get there. So if we fix y, let's do this. Now, if I fix y, I'm just going to have a function in terms of x. So let me just call that h of x. Okay, I'll just call that h of x. And I'll just use h as the name of my new function here. Now, if I let y be 2, here's what I get. I get x squared minus 6x. Now, minus, what is this? So now, y is 2, so this is 4. Plus 4 minus 6x. Okay, there I go. Now, is everybody okay with that? I squared 2 and got 4. Then 2 times 2 is 4. And then here's negative 6x, negative 6x. Okay, so it looks like what I've got then is I've got x squared minus 12x. Is that right? Okay, now, so I've got this new function. So what I'm doing is I'm looking up at this curve. I'm in this little region over here. I'm looking up, and right now, I'm on this line. See, I'm just standing on this line looking up. And what I want to do is I want to see, okay, is there a high point or low point on this curve over this line? Well, this is the curve over that line. So let me just find the derivative. If I look at the derivative here, I've got 2x minus 12. 2x minus 12. And that gives me, if I set that equal to 0, that gives me that x is equal to 6. Okay. So what I want to do with that now is I want to go back and say, I want to calculate this. I want to calculate 6, 2, and see what that turns out to be. Now, I'm going to just leave that there for right now because I don't want to get bogged down in the calculations. We can go back and calculate that. Now, I want to come back and look at this. I want to say, well, what about when y equals negative 2? Okay, so now we're down on this line right here, and we're looking up at the surface. And we want to say, okay, directly above this line, what is on this surface? Is it another parabola like that? Well, let's see. So we've got h of x is going to be equal to, same thing, x squared. But this time, it looks like it's going to be positive 6x, right? Positive 6x minus 4, just like before. And then minus another 4, right? And then minus 6x. Okay. Does that look right? Okay. So let me just make sure I've got negative 2. That's going to make a positive 6. And then negative 2, there's a positive 4. I mean, well, negative 4 because it's got a negative in front, another negative. and then a negative 6x. Okay, so it looks good. So now we have h of x is equal to x squared minus 8, and we want to differentiate this one. Okay, so here we go. Let me differentiate. Okay, x squared plus 6 minus 8. Okay, so now we take the derivative and we get 2x equals 0. That means that x equals 0. And now I can plug that in, and what I get then is I've got I've got 0 and what was it? 0 and negative 2. Okay? So these are things that we're going to consider here in a minute. We're going to plug those in and see which ones are bigger. Okay? Now we can go up and we can say, well, what about when x is equal to negative 2, or negative 3, I'm sorry. When x is equal to negative 3. So you see how we're having to do this? We're having to consider every possibility. So when x is equal to negative 3, let's see what we get here. When x is equal to negative 3, I'm going to say h of y this time, right? So here's what I get. I get 9 negative 3 squared plus 9y, and then minus y squared plus 2y. Now remember, we're saying x is negative 3, so this is plus 18. Okay, so you can see you're likely to make a mistake in this. But so you have to be very careful. Negative 3 squared is 9. And then we've got a negative times a negative is a positive. Y squared plus 2y plus 18. Okay, looks good. Now let's see if I can simplify that a little more. H of y is equal to negative y squared. Okay, 11 plus 11y, and then plus 27. And I'm going to differentiate that one. I differentiate that, and I get negative 2y plus 11 equals 0. And that means that y equals 11 halves. Okay. Now, as long as I'm not making any mistakes here. But so here's what we've got. We've got to find this point. F of negative 3, 11 halves. Okay, we've got one more line to consider, and that's when x is equal to positive 3. So we'll say, okay, x is equal to positive 3. And then we've got h of y. Now, if we've got h of y at positive 3, we've got, let's see if it's going to be any different, 9 minus 9y, and then minus y squared. Nothing's changed so far. Plus 2y, and then minus 18. Okay. So a little bit changed on that one, but not much. 9 minus 9y minus y squared plus 2y. Yeah, okay. So putting it all together, I've got h of y is equal to negative y squared minus 7y, right? And then minus 9. Differentiate that one. And we get negative 2y minus 7 equals 0. And so we've got this point, y equals negative 7 halves. So I've got to find f of 3, negative 7 halves. Okay. So what we've got now is we've got a point from all 4 of those lines. Okay. So we looked at the curve directly above that line. Now, so what we've got to do is we've got to actually plug this in and get that value, plug this in and get this value, get this value. And where's our other one? and this value, right? But that's not all. So we plug each one of those in, and then we also find these. F of negative 3, 2. We find F of 3, 2. We find F of negative 3, 2, negative 2. And we find F of 3, negative 2. Now, so we've got 4, 5, 6, 7, 8. We've got 8 points to plug back in the function. Whatever the largest value is, that's our maximum. Whatever the smallest value is, that's our minimum. There's no max or min on the interior. The max or min in the interior just gives us a saddle. That's all it gives us. Okay? Now, here's what I want to do. I want to look at one more thing. Does anyone see anything that's happened here that maybe will make my job a little easier? Anybody see anything? Look, x has got to be between negative 3 and 3, right? Ah, look at this one. Look at this naughty rascal. X can't be 6. Okay? Ah, things are looking up, right? Now, it looks like this one's okay. Now, this one, look, so what about 11 halves? Ah, that's too big of a y, isn't it? Okay, all righty, so I was able to reject those two. Now, what about 3? Okay, 3. 7 halves, that's negative 3.5, isn't it? So can I throw that one out? Ah, good, good. So it looks like what we've got to do is we've got to test this one, and we've got to test those 4 down there. We were able to throw out 3 of those. Right? Y'all see that? Okay, so once we plug those in and test them, we can find our maxes and mins.